Alright, so for geometry, we're looking at Chapter 4, Section 4 today. And we're going to look at what happens when we reflect over two parallel lines. So we're going to compose reflections over parallel lines. So what that means is we want to first have a pair of parallel lines, reflect over one of them, and then reflect back over the other one. So if we kind of just get a general idea of what that would look like. So we've got two lines here, L and M. And we're going to say that L and M are parallel. So you guys remember the symbols to mark that two lines are parallel. And if we want to take a point here, then let's call that point P. We want to look at the reflection over line L of point P. And we know that that's going to go to P prime. And then we're going to take P prime and we're going to reflect over line M. And that's going to give us a new point, P double prime. So we could actually write this as a composition. And from a composition, the way we would write this as the reflection over line M of the reflection over line L of point P. So these two things together mean the exact same thing as this. And we work from the inside out when we're talking about doing this composition. So those two things together are going to give us this value P prime, and we're going to try to see if we can figure out where that's at. Now you guys might remember in class we discussed maybe cheating a little bit here and doing this using some paper rather than a straight edge and a compass. So if you look, I put this line directly on my parallel line L because I want to reflect over L first. And it looks like I go 1, 2, and just a little bit more than that next line. So I'm going to go 1, 2, and just a little bit more than that line. And I'm going to call that point right there P prime. And we're going to say now that we had this to be perpendicular. So here we have this segment that's perpendicular to line L, and we have that these two distances are the same. And we're going to call those two distances both x. Now the next thing we want to do is we want to take P prime and we want to reflect it over line M. So again, I'm going to use my method here to put this line M so that lines right up with that blue line. And it looks like I'm just under a full line away. So I'm going to go just under a full line away, make my point. And again, we should hopefully be perpendicular. And now these two distances should be the same. And let's call those both y. So what we have here is we have P double prime after doing a double reflection. And it's hard to see with just a single point, but if I were to take a whole triangle and reflect it, so say we have this triangle and we reflected it over. And then we reflected it over again. You'd see that if I number the sides 1, 2, 3, they would correspond to 1, 2, 3, which again reverses the orientation. We've talked about that in a previous section. And then when we reflect it again, the sides would be 1, 2, 3, which would reverse the orientation back to the original triangle. So we could have gone from this first triangle to that last triangle by doing the double reflection, or we could have simply taken this triangle right here and slid it across the plane in that direction. Now the question is, how far do we slide it and in what direction? So we have to kind of discuss what that would be. So this kind of operation, or this kind of transformation, when we reflect over two parallel lines, so we get another kind of transformation by doing two reflections. And the transformation that we get by composing two reflections together is what's called a translation, or a slide. So we get this translation or a slide by composing two reflections over parallel lines. So it's the composition of two reflections over parallel lines. And what's nice about a translation or a slide is that it is described using what's called a vector. And so a vector in mathematics and in science class, when you guys get to physics, you'll see this. A vector is something that has both magnitude and direction. And magnitude, that's just a fancy word for size, or in our case here, length. So it's going to have a size or a length and a direction. And to figure out what that is, for our translation by doing the two reflections to get the magnitude, we can look at the distance from P to P double prime. So I want to look at the distance from P to P double prime, which, if you look up here, happens to be, well, it's x plus y plus y. So it's 2x plus 2y, or 2 times x plus y. And the other thing to notice is that x plus y just happens to be the distance between lines L and M. Not a coincidence. So this magnitude or this distance is really twice the distance between those parallel lines. So we figured out how to calculate that magnitude. And the next thing we have to figure out is the direction. And what's nice about the direction is that both of these angles, by construction of, or by carrying out the reflection, happen to be right angles. So we can use that idea of perpendicular to help us figure that out. So the direction is that it's going to be in the direction perpendicular to line L and M, and it's going to go from L to M. Because notice that we want to go from P to P double prime, so we want to travel in the direction from L to M. It's also, notice over here, that we reflected over L first and then M second. So it's the direction from the first line we reflected over towards the second line we reflected over. So this direction is going to be the direction from L perpendicular to M. So it's from L perpendicular to M, And the reason it's from L is because that was our first line of reflection. And it was towards M because that was our second line of reflection. So, just like you guys saw in the past, we're going to use this idea of reflection to create some new transformations. Notice that since we did two reflections, we talked about before that reflections preserve length, angle measure, collinearity, betweenness, so we've got these four things that are preserved by reflections: length, angle measure, collinearity, betweenness. And we saw that, I guess the other thing is that they were one-to-one was preserved. And there was one thing that reflections reversed, and that was the orientation. Since we put two reflections together, if the reflection preserves all of these things, then that means that doing two of them is still going to preserve it. So a translation would also preserve all of those. And we also get the nice thing that since we did two reflections, if we reverse the orientation and then reverse it again, we're back to the original orientation. So not only does it preserve these five things, but it also preserves orientation. And that's because we've simply taken something that before we reflected twice, and we've done a translation with it, which means that we've simply taken our object and we've slidden it to a new location on the plane. So that's all a translation is. It's taking your object and sliding it to a new location. And that's it for Chapter 4, Section 4. So two reflections over parallel lines gives us a translation. And next time we'll look at what happens when we reflect over two intersecting lines.